start off with the CPU. It's an Intel Core i7-3930K. It's a socket 2011 design, 3.2 GHz, 12 megs of cache, and it runs at 6 cores. The CPU itself is a bit different to other mainstream socket 1155 CPUs you see in the 2700K, 2700Ks. This is what they class as Sandy Bridge E, which is the enthusiast range of CPUs from Intel, and it doesn't fit on anything other than socket 2011 boards, which we have for our build here. Now we can tell it's an enthusiast chip because Intel deem it not necessary to give you a cooler with it. So this is the retail package, and all it is just the CPU itself. I think Intel think that given that you're going to spend so much money on a CPU like this, then you're probably going to want to go for a third-party cooler, which is why they don't include one. So we've done that. We actually had to order a separate third-party cooler to get a cooler to work with this CPU and board. The CPU itself, like I say, is currently the fastest Sandy Bridge CPU you could buy. Now, there's been a lot of talk about Ivy Bridge. Ivy Bridge is a successor to Sandy Bridge, and it's been launched recently in the UK or worldwide, but it hasn't really made it to the mainstream yet. In fact, there are no Ivy Bridge CPUs which are faster than this, and there won't be for another 6-7 months. And when that happens, Intel will launch probably later on this year Ivy Bridge E, which will be using the same chip as the socket 2011 as the CPU currently is, which is great because it means that the board we're going to be using will be compatible as well. Mainstream boards at the moment, socket 1155s, are taking the current Ivy Bridge range, but they're still got a bit to go to beat this CPU itself, and obviously it'll be a few more months before we can see Ivy Bridge CPUs overtake this. So maybe in 3-4 years, if the customer wants to upgrade, instead of ditching the board and CPU, you can just take the CPU straight out the board and put a new Ivy Bridge CPU straight in, giving him a future upgrade for another 5-6 years. So it's a good choice for the moment. Over to the motherboard. We're going to be using an Asus model, X79 Sabertooth, and here it is. It's quite plain looking considering other Asus boards of this type. And really there's only a few new features here. Like with the case, I won't be going into this in too much detail. There's plenty of videos on YouTube showing this motherboard out. What there is to note is that there's actually 8 DIMM slots here, so you could have 8x8, which is 64 gigabytes of RAM. Now we've gone for our build only 16 gigs of RAM using 4 gigabytes DIMMs, but there's nothing to stop you from putting 8 gig DIMMs in here. The reason for that is that the customer doesn't need anything more than 16 gigs, and doing it this way means that after we put 4 sticks in, there's room for 4 more, so you could upgrade later on to 32 gigabytes if you wanted to. Another feature about the board which is quite new is this, it's been coined thermal armor by Asus. It sounds very fancy, but what it is a couple of new fans above some of the chipset areas and around about the backplane. This is used to help push heat away from these areas which are normally quite hot to maintain performance and efficiency. This coupled with Asus's new thermal radar, it sounds quite cheesy, but thermal radar is a term coined by them, and they're always coming up with new terms like this. It sounds very fancy, but what it is around the board there are different sensors which monitor temperature, and with the utility that they give you, the board itself will monitor the temperature in different areas of the board, so thermal radar. And if it gets too hot in certain areas, the utility will actually turn on the fans in a particular way by speeding them up or slowing them down. Not only these fans, but also the case fans as well, to try and push away that heat. So it's a great way of monitoring in the background without you having to do anything. So automatically we'll measure the temperature constantly, and then if it gets too hot here, we'll turn the fan on, cool that area down, and then generally just improve the airflow and the cooling around these critical areas, which is quite a nice new feature. Well, that's pretty much it. The only other thing I would point out, there's actually a USB 3 header here, which is one of the first boards I've seen it on, and our case has a USB 3 header as well, so it's a bit different to the regular USB 2s, but there's just here, the little green little slot there. Besides that, that's pretty much it for this board, so I'll put it down, and we'll move on to our graphics card. We're going to be using an Asus model again. It's GTX 580 Direct Q2 The direct Q is actually a play on words. In fact, the Q stands for copper. There's actually two copper heat pipes here, which are actually bonded straight to the GPU itself. This gives it superior cooling, according to ASUS. And it looks like a beefy card. In fact, the card itself is actually quite thin, but the cooling they've rammed on here is huge. It makes the card very heavy. There's not a huge amount to say about this card. Again, YouTube will help with that. There's a couple of 8-pin power connectors there, which are quite standard for this kind of card. But what there is special about this card, and the reason why we're going to be using it, is that it supports something called CUDA. And CUDA is basically a method of offloading intensive tasks that which your CPU normally has to undertake onto the graphics card, which is usually lying dormant. Now, for the purposes of our customer, he's going to be doing a lot of video editing, and the CUDA cards can actually accelerate the process of video editing tasks by quite a lot. So, incorporating a card that supports CUDA will allow him to do video edits and transformations and conversions a lot faster than he would do if he just had a regular CPU. Nvidia have CUDA. ATI have their own version as well, but at the moment CUDA is probably more of the standard, and ATI have a bit to catch up because the applications that we're seeing are normally CUDA optimized and not. And the ATI don't have an equivalent just yet, so maybe that will change in the future. Moving on, the RAM we're going to be using is Corsair. It's the Vengeance series, and we've gone for a DDR3 1600 MHz, and we've gone for 4 DIMMs. It comes as a kit. It's pretty straightforward Corsair RAM. It's got a fancy heatsink on the top of it, and it's reliable. It's got a lifetime warranty, which is the lifetime of the product, not lifetime of your life, but lifetime of the product itself. So it's very good RAM. What else do we have? Storage. Now we've gone for a couple of storage options. The first one is SSD for the main Windows and program drive. It's Agility 3 from OCZ, and it's 120 gigabytes. Now we go for this one because it's one of the fastest SSDs you can actually buy. It's rated at 500 megabytes, which effectively means that if you had a 4 gigabyte DVD file and you wanted to move it from A to B in the drive, it will take about 8 seconds, which on a conventional drive will take you about probably about 20 or 30, 4 or 5 times slower. So it's a super quick drive. Once we have this installed, the applications will run a lot quicker, and you will notice things like Windows starting up very quickly as well. In fact, with this SSD installed, I reckon we'll get boot up into Windows in about 15 or 20 seconds from cold, which is pretty awesome. Coupled with that, we're going to be using a couple of conventional hard drives. I say conventional, but they're actually one of the fastest drives you can buy. These are Western Digital 2 terabyte Caviar Blacks. They're rated with 5 years in their warranty, which is 2 years above any other hard drives you can buy. So they really are well designed and well thought about. The hard drive itself is been optimized to run cool, and we're going to use it in an array of RAID array, what we call a RAID 1 array. We're doing this because the customer will have large files he wants to protect, and he doesn't want the risk of losing them. So we're going to set it up as a RAID 1 array, which means that any file written to one drive is mirrored automatically to the other drive. So if one drive were to fail at some stage, the other drive will still have the data. So that's going to be that. Finally, we'll have a couple of optical storage options. We're going to be using a regular DVD burner for CDs and DVDs. It's a multi-DVD burner and supports plus, minus, RAM, CDs. These were about £2,000 when they first came out, but now you can pick one up for about 30 quid. So they're actually very good value. We're going to use that for our everyday tasks, but every now and then the customer might want to burn a film onto a Blu-ray disc. That's why we've got a LG 10-speed Blu-ray burner here as well. The idea is because this drive is so much more expensive, we won't want to use it or wear it out, so everyday tasks will be using the DVD burner and CD burner, and if you want Blu-ray to read or write, then you use the LG burner here. We're going to be using Windows 7 64-bit Home Premium. Now, we could have used the professional version, but there was no point. The customer didn't need to hook up to a domain. So to save a few pounds, we've gone for the Windows 7 64-bit Home Premium. 64-bit is important because it allows you to use more than 3.5 gigabytes of RAM. Otherwise, you'll be stuck there. So the 60 gigabytes of RAM will be fully supported by our Windows. we're going to be using also Corsair modular power supply. It's TX650M, and it comes with a whole bunch of cables and connectors. Now, the good thing about modular supplies is that you don't need to plug everything in. You just need to plug what you need to use. So you may see cases in the past with all the cables just chucked in. With these modular supplies nowadays, you can just make your case very tidy by only using the cables that you need. So in time, if you had another hard drive, you can then get another one out of the pack and put it in. But it kind of improves on airflow because you don't have to have all the cables just chucked in there. And they're normally quite hard to tidy as well. So that's great. The Corsair supply is a 650 watt and it's 80% efficient, which means that it's a very efficient power supply. It comes with a 5-year guarantee, and it's going to be a good basis for our build, as it's a very reliable brand. To top it all off, we've got a Wi-Fi stick from Netgear that the customer wanted. He works in an office and he hasn't got the ability to wire a cable, which is a shame, but the next best thing is to use a more reliable wireless adapter, which is what we have here. So there you have it, all the parts for our build. So really looking forward to this. Maybe once we're done, we can get a really good rating in Windows experience, but I guess we'll have to wait and see till we finish the build and actually test it to see what kind of rating we'll get. So thanks for watching. Thank you.